Hi, in this video we're going to discuss linear functions. You probably already know what a linear function is, but we're going to be looking at it from a slightly different perspective. In particular, we're going to think about linear functions in terms of average rate of change, which you've already seen in earlier videos. So the average rate of change formula is here, and what is special about a linear function? Well, it's a function, say f, so that no matter what a and b you plug into this average rate of change formula, you always get the same number. We say it's constant. Doesn't depend on a and b. This constant is usually denoted m, and it's called the slope. We'll see why in a second. In this video, we're going to talk about linear functions from the four basic perspectives. We're going to think about them in terms of graphs, and we're going to think about them in terms of formulae and words. And actually, in a separate video, we'll talk about tables because there are special things we need to discuss there. So let's get started. Let's think about linear functions in terms of graphs. So here I've drawn an xy coordinate system, and what's important about linear functions is that the average rate of change is always the same number, which we'll call m. In this example, let's think of m as being equal to 1/2. So that means the average rate of change is always equal to 1/2 no matter what a and b I choose. Let's also suppose that the y-intercept of our function is at 2. So this is the y-intercept. This is the place where the graph of the function is going to pass through the y-axis. So just knowing that y-intercept, we can actually determine the rest of the function, knowing also that we have a slope 1/2. Why? Well, we can think of 2 as the difference between the a and b values, the x values, and 1 is the corresponding change in the y's. In particular, if we start here at 2 and x value 0, we can, if we move 2 units in the x direction, that's this 2, difference between b and a, we'll get here, or up in the graph here. Then we know the corresponding change in the y values is just 1, so we'll move up 1, so we'll move up 1 here. Right? So you probably recognize this, we're talking about rise over run. So the rise here is 1, the run is 2. This is the run, this is the rise. In terms of the values of the function, in terms of this formula, I'm using 0 as a, 2 is b. F of a, that's 2. And f of b is 3. Okay, so I could. What's great about linear functions is I can change the a and b, and still I'll have the same ratio, rise over run. So f of b minus f of a over b minus a doesn't depend on what a and b I could choose. Let's shift, in fact, the a and the b over. So I'm going to now use a is 2, b is 4. Well, that says then the f of a and f of b will also shift. F of a is now 3, and now f of b is going to be 4. That is, if I now rise 1, then I run 2. I run 2, rise 1. The new point, b comma f of b, is here. And I can also do this at other scales. I can look at rise over run instead of being equal to 1/2. Well, 1/2 is the same as 1/2 divided by 1. That means I could take the rise to be 1/2 and the run to be 1. That's the same as 1/2. So I could start here, for example, run 1. If I run 1, that's the same as rising 1/2. So I get a new point here. And I could use that elsewhere too. I could do the same here. I can do the same. And what I see is a sequence of points on my graph here, 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 here. They all lie on a line. Okay, so the upshot of this discussion is that the graph of a linear function is a line. This rise over run, m, is the slope of this line. This is called the slope. In this case, the slope is kind of shallow. It's only 1/2. If instead we had a 2 divided by 1, then we get a steeper line. So that's why it's called the slope. It measures how steep the line is. Okay, so that's how we think about linear functions in terms of graphs. Let's think about words. What happens with linear functions and described in terms of words? Here are two examples. In the first one, we have the production of CO2 by the coal industry rose at a constant rate of 5 billion cubic meters per year. Why is this a linear function? Well, the key words here are constant rate, because we have a constant average rate of change if we have a constant rate, and constant average rate of change means linear function. So having a constant rate is linear function. So in this case, the slope of this function, the rate of change, the average rate of change, is 5. But in a word problem, you have more than just numbers. You actually have units. And here, the units are billion cubic meters divided by a year. That's the units, 5 billion cubic meters per year. Let's look at the second example. The balance of a bank account decreased at a constant rate of $10 per day. Again, the telltale sign is constant rate. That means you got a linear function. In this case, the slope, the rate of change, is 10, but the units are dollars per day. So these are two examples of linear functions given by words. The key is having a constant rate of change. Finally, let's look at formulae. What's a formula for a linear function? Well, again, let's appeal to the average rate of change. The average rate of change for a linear function is constant. So that means no matter what b and a I choose, I still get m, that number m, the slope. So I could choose b to be a variable, x, and I could choose a to be equal to x1, which is kind of standard. And the average rate of change formula becomes f of x minus f of x1 divided by x minus x1, which is equal to m. Now I'd like a formula for f of x. So I'm going to solve this for f of x. So now I'll multiply both sides by x minus x1. I get, well, the numerator remains, but the denominator goes to the other side when I multiply by x minus x1. And now I can solve for f of x by adding f of x1. So I get f of x is equal to m times x minus x1 plus f of x1. You know this formula. You've seen this many times before. This is normally called y1. This is called y. So this is the same as the formula y equals m times x minus x1 plus y1. This is the point slope formula. And this is key to doing problems in this course. So if you haven't already memorized it, you should do it now. It's the all-purpose formula for linear functions. Okay, this has been an introduction to linear functions.